Thank you for coming. So today my talk is, well, already have the title, but the subtitle is very long. So you will find out very soon why this is a long subtitle. It's hard to explain, but in the next few slides, you're going to find out why this is special and how we are going to build this Kubernetes cluster thing. So before anything, we need to have a context. I work in a company called Startree. We sell something called Pinot. So I'm not going to talk about how awesome Pinot is. For example, how fast the query can be, how can be scaling up, whatever things. There are people in my company just trying to do that. So the context here is that we have this cluster. It needs to be managed and deployed to the customer's environment. It runs a lot of query, and it needs to scale up, scale down, whatever things there. Now, what happened? Oh, sorry. I think I pressed the wrong button. OK. Now, for traditional SaaS company, this is the setup for traditional SaaS company when they provide SaaS service to the outside. Now, the important thing is that all the Kubernetes cluster actually are inside the SaaS company's network. So when you want to do SaaS and do data, typically the user just customer, we call it, dump all the data into our cloud and we store them for them. So this is fine and it's a very typical setup. But for us, we do something differently. Now the network here is actually critical, the boundary. So all our customers, we can manage all these Kubernetes clusters just inside our customers' virtual private cloud. So the example here has the AWS Kubernetes cluster. We have GCP. We have Azure. So all their data and the Kubernetes cluster are actually inside their own network. This is important, but why do we do this? Because what we sell is data, Pinot, right? So data is a very heavily regulated area. So there are compliance requirements. The data need to stay inside some place. There's security concerns. So this makes the customer want to keep the data and computing resource here, the cluster, inside their own place. They have control. Then they still want us to fully manage this for them. So this was not possible before Kubernetes cluster or Kubernetes ecosystem has matured. Right now, Kubernetes is in a stage that we can actually provide this solution to them. Now, this is important context. Wrong button again, sorry. OK, so we are going to talk about architecture. When we do architecture design, the most important thing actually are constraints, trade-offs, and limits, whatever things there, boundaries. So here, for our design, I summarize into 3 constraints. One, on top is the customer's cloud. So the Kubernetes needs to stay there. And secondly, we provide Apache Pinot. This can be actually a blessing for us because we are limiting our scope. We are not trying to rebuild like AWS, whatever, right? And we need to be able to scale up. Scaling up in infrastructure and cloud side is actually a lot harder than the typical, like if you have query, you want to scale query up to a million QPS, it's possible. But for us, I think thousands is the goal we want to have. So keep this context in mind. We'll come back to visit it, and it will just impact our design. Now, how do we design this system? So I'm a huge fan of ChatGPT, so I actually asked this question to it. So it came out with a very good answer for interview. Like if I'm going to hire someone, it has a good answer. So, but I promise I'm not writing this one by ChatGPT. It's all handcrafted by me. So anyway, if you're interested, just ask it. It actually provides some general concept. So what we are going to do here is that I'm going to, just like this tortoise trying to climb the scales, we try to do things like manually first, and then try to automate, and then try to build our system, and eventually we'll come out with a system that can just scale up the Kubernetes cluster. Now, this is a context that we still want to visit. Now, the first step, we want to create a cluster. So when the user comes to our system, and they want to just say, we actually want them to be able to provision the cluster by themselves. So there will be something like having a UI, so they just do this dialog and select minimum things, and then click OK. And a Kubernetes cluster magically show up in their network environment. Now this looks OK. Then how do we do this in a system design? That we start from manual way. So manually, if we do this, we need to use the credentials provided by the customers, however way they have, like IAM, whatever. And we create a network account, we create network, we create like a Kubernetes cluster in the UI. But if we want to automate this, we can say, I want to write a script, and then, but don't do this. In your code, actually, we should do this by our, what we call microservice way. So we wrap all these features around our microservice, and we can call into this service and finish all the jobs. So it can be some code wrapping around AWS client or other cloud client, but we chose Terraform. It's not perfect, but it's very good. So we just wrap around this and call into this Terraform module, and then it will just create a cluster for us. Now, with this infra, we call infra as a service running in the background, and we actually can do this automation easily. Now, in this diagram, we actually have, well, the initial steps, what we have. So I'm DevOps. I don't even draw the UI here, but anyway. We have a cloud backend here that, of course, we want to keep track what cluster has been created by who, and there are other things like organization, whatever. So we have a metadata store here. We also store the customer's credentials in case we want to do upgrade or other things. So we actually put it in a secure storage we call Vault. There are other choices there for sure. Now with this, we can actually interact with the cloud provider. We can say send the RPC command, and then this service just eventually show up this Kubernetes cluster in each network. Now with this design, can we scale to 1,000 customers? Actually, there's one piece that is missing here. I'm calling this as an orchestration engine, or it's called a workflow engine. So why do we need this? Now think about when we create this new cluster. There are many things we want to do, right? We want to create an account. We need to create node group. All these calls are actually RPC calls into the cloud provider. They take time. Sometimes they fail. There are dependencies. So we don't want to wrap this, for example, 6 steps in one function call. What if something fails in the middle? Do we want to retry? What do we want to do? So this kind of steps, finish, checkpoint, retry, actually it's already in the outside. It has a solution there. It's called workflow management. There are single node solutions. There are distributed solutions, for example, like Cadence, whatever. So just grab one, implement it, and we can actually have this. So I think with this in place, we are actually able to create this cluster without too much human intervention. So the next step we're going to do is we try to install applications. So for each customer, when they have the Kubernetes cluster, we want to have this dedicated networking environment with the application listed. This is the actually Pinot controller, so they can just try to run some ad hoc queries, play with it. There are other apps like Data Manager we call doing ETL job. So to do this, there's also the manual way, right? The typical thing is just kube control, apply, just write something. But never do this in your application or production because it's tend to get lost. The least we can do is do HEM. It will help you. But to do it with automation, we actually do things like we build our own HEM charts. We run our own HEM repo, or we paid AWS to do it. And then we can deploy just by Helm install. And the Helm client is actually wrapped also around our services. So the installation can be done. And then the end result is that our customers' Kubernetes cluster runs as a platform. So we can install all these apps in future, whatever you want. For example, the Prometheus, Grafana, whatever we have, just install the Helm chart, is showing up. The good thing is that the Helm chart and Dockers are owned by different teams. So our DevOps team, cloud team just say, go ahead. It's not our responsibility anymore. Right. Now, with this, we actually have the networking, we have the platform application up. There are next steps, The networking. Networking is a huge topic. It's worth a dedicated session. Actually, there's our friend Scott McAllister is actually doing a whole talk about ingress right now. Just don't leave and check the recording. For us, I'm not going to go into it. So for us, the special thing is that we have the requirement of public-facing or internal-facing. So sometimes the users say, I don't want my cluster exposed to the outside. I want to do VPC peering. So nobody else except my network can access it. So it's fine. But for ingress setup, Kubernetes actually has very good model around it. We just find one solution. So we just chose traffic. It's now fully evaluated or benchmarked because it's not so critical for us. We chose it, as I say, it's convenient, it's easy for teams to set up. So it's a good solution. It doesn't mean that it's the best. There are other things we need to set up. For example, the load balancer, it's actually not perfect for each cloud provider, but it works. And there are other things to consider, like multi-zone, multi-zone high availability. So there's always small things there. The thing I'm going to talk about deeper is actually the certificates and TLS. So this picture is my personal nightmare, debugging. Certificate debugging is painful, really painful. But our customers actually ask for it, even they have a VPC, because this is a security standard, right? Now, if we want to manually generate certificate, it's not going to scale. If you have done this before, even manual step is painful. Certificate also has a typical thing that it has an expiration date that if you get a cheap one, it's usually 3 months or 6 months. So basically, in our code, renewal, so renewing the certificate is the same thing like first time generating the certificate. Now, this is a quick refresher of what certificate is. I believe you all know it, but we need to refresh our memory. What does certificate do? It only proves that you own this DNS domain properly. So if you want to generate certificate, you need to do a lot of challenges. Say, prove that I can own this domain in a DNS protocol. Now, there's a chain of trust, but the thing is that it is usually issued by well-known third-party issuers like ZeroSSL or like Let's Encrypt. So now, to refresh our certificate or regenerate certificate, there are two choices we can have. First one, I call this centralized solution. So it's actually worth looking a little bit that we have two customers here. One is we call Awesome Corp. So it owns a domain we call subdomain, our cloud. So it has Awesome, whatever. And the second customer has a different domain here, the best company, whatever. So they all need their certificate. Who own that, this cluster actually owns this domain properly. Now, we can just say, I write with something called certificate refresher. So it tries to talk to this issuer, we call ZeroSSL, and try to generate certificate. Somehow there's we call downlink, that it can just try to download this certificate and then install them locally into that cluster. So this one is plain simple, but it has a very good security too. But it has problems that when we get to, say, 1,000 customers, it's actually now easy to scale up. The second choices we have is actually we call distributed or decentralized renewal. So here comes the famous, we call certificate manager. This is actually an application that tries to generate a certificate for you inside a cluster. And when the time comes, it will try to regenerate for you and install properly. So it's basically everything we want to have. For this specific example, we actually send down the credentials for this domain control into submanager. And submanager tries to talk to this, we call issuer. And all these things just handles by themselves. But this one also has a challenge. What is it called? Security, actually. So the most important thing we want to do is that for this customer, what we give them, because this is owned by our customer, we don't want this customer who has Kubernetes control try to grab these certificates or whatever we call credentials and mess up this customer. This is important. So what we want to do is that we need to control these credentials, only controls this one. So in AWS Rule 53, it's basically, we call sub-hosted zones, where each customer will have one hosted zone. And here, we also need to be careful that if we talk to zero SSL, this one cannot use these credentials talking to zero SSL and then mess up the other one. So it's a very delicate situation that we need to be very careful. But this one can be scaling up easily. Now, with this connection, we are very close to create everything we have. So I'm going to skip the remaining stuff. It's very tedious. We had to set up the authorization, authentication. We had to have logging. We have monitoring. We have backup, debugging. So the thing special for our solution is that the metrics, we need to push to our centralized logging. And we also need to push them into our customers' environment. It's not difficult, but it's something like data security, if we need to be careful and make sure the customer are aware of that. And the backup has to be done into our customer's own storage. We can't backup into our place. That violates the data regulations. So with everything, we actually need to have a checkpoint of our architecture. Now, we have this cloud. We have orchestration engine. We also have the backend here with the storage. We have infra as a service, so we can talk to the cloud. And we have a centralized monitoring. We can renew like certificates. So from the customer side, they actually can install all sorts of platform applications. And we have Pinot cluster. So this is basically a Kubernetes fleet management. So if you go out and search on the internet, you actually can find something like kubesphere. It allows you to install applications into Kubernetes cluster and manage them in a UI. Now, it's almost there. There's something still missing. We haven't talked about the Pinot. Now, this is definitely going to be another tech talk from my company. It's not being talked about in the outside yet, but we actually implement something called Kubernetes operator for our Apache Pinot. So Kubernetes operator is built based upon we call Kubernetes operator framework. So what is changed? Maybe I can show an example. So for example, Pinot has a capability to scale up. For example, I want more servers, increase server from 3 to 4. The easy way is just say we go through the Kubernetes control and like scale up, scale stateful set, but don't do that. So what we do is actually the user will go through our cloud and say, I want to scale up, so there's a UI somewhere, change this like a replication equal to 4, so I want to 4 server. So there's something called custom resource inside Kubernetes cluster will somehow get modified upon by our cloud. And this could Pinot operator will monitor this custom resource. It runs inside a Kubernetes cluster to say, oh, someone changed the numbers of servers into 4. So it will try to call into the Kubernetes API and tell Kubernetes that I actually want another replica new server. So this one will just interact with the Kubernetes framework. And Pinot will eventually get another server shows up. So this one is very powerful. It takes some time to write, but it's basically what typically distributed system they run. For example, Kafka and other like distributed system, they basically write something like this. We also do that. Now, what else? Configuration. We call knobs or config. So each customer will want different configurations. We need to meet their demands. For example, there's something called Groovy in our Pinot query. So some customer want it, the other customer doesn't want it. There's no way to make everyone happy. So what we do is actually, we provide this something called knobs and config, and what our cluster looks like, we have something called template. So we have this config engine, we try to say, we compute what the cluster will finally look like. We call cluster spec. And then the Pinot, we call custom resource, run by the operator will be someone actually part of this spec. So it's a typical Gantt 4 visitor pattern. So actually the old pattern is still sometimes helpful. Now the plugin mechanism actually is sort of a design coding pattern. So it's not a critical thing, but it works. No. So we are almost there, but we are missing this, what do you call, ops part. So we have all the design in place, but we don't have operation yet. So speaking of this ops, actually, maybe I will try to tell something about my daughter. So my 8-year-old daughter, you know, they can be cute, but they are sometimes also annoying. So actually, when I wrote this slide, she sneaked up upon me and tried to read out loudly everything I type to the whole room so they can know it. So she said, the oops part of dev oops. So it's I laughed, but after the laugh, I thought she's actually right. The next few slides actually are all the oopsies of DevOps. Our lives are full of it. So it could be do DevOps, but anyway. Now this is actually one conversation that actually happened for our support and our customer. So this guy with the helicopter hat is our support. So the guy told the customer, we need to update your cluster, right? This is a version upgrade. So the customer said, don't touch my cluster for this month. So, but the Kubernetes is end to life, right? The node will go down, but I don't care. So anyway, in fact, don't care about, don't make the hardware failure. But how can we? But this is real life. So what we end up of the version operation upgrade is something we call version matrix. So each customer has its own Pinot version, has a platform version, has a Kubernetes version. So it's basically a matrix we will see. Different versions showing up everywhere. Now, to manage this version matrix, there are some actually good lessons. We have learned that first thing is the release pipeline with the very good test is going to help you. The second thing is we need to have discipline. Never release versions that have breaking changes from other versions. Imagine one version that is not compatible with other versions. It's going to have a nightmare in a version matrix. But if you really want to make breaking changes, what do? We make sure all the incompatible versions are gone first. Usually people don't downgrade, right? So we have one version that is safe for everything, and then we can introduce the new version with changes. Now, the simple thing is like a Helm-chart version image tag is just a simple thing to keep your life easier. Otherwise, you will have another 3 or 5 versions. Now, the other thing about ops is the efficiency and reliability. So this is a viral image I copied from Reddit. It's actually have a commuter trains running on top of it. So it's lacking, we call maintenance. So no good architecture is going to save you from this. I imagine this as a sort of a DevOps maintenance thing. If you have good DevOps running things, something's wrong, we just reinforce it, right? But anyway, the point here is that for DevOps, the discipline is important. We need to have as few outages as possible. And because we have this role, we have end-to-end ownership. That's important because it actually helps. Now, there are also some lessons or experience we can try to share that it helps. For example, we need to have infer, we call regression tests or integration tests. It's expensive. For example, if we test that we create a Kubernetes cluster and destroy it, and if the test goes wrong, the Kubernetes cluster sits there for maybe a few hours and it costs money, but it's actually worth it. We need to do this kind of test. And for release pipeline, try to do trunk-based release pipeline. Otherwise, there's things that you don't know in a branch that messed up things. The third thing is kube control command is helpful to customize your things, but you tend to forget what you have done. And at some point, you just lose track of everything. So don't do customization by kube control command. Always try to say deploy from somewhere, or use the standard way. Even hand char is better. So that's probably a few things. The next thing is the operations and on-calls. So there's no silver bullet here. On-calls are just life, and we need discipline. So root calls, follow-ups are very important, especially the follow-up. If you don't follow up, it's going to repeat. And the alerts part, what I have learned from my maybe a few years of experience is that we need to differentiate alerts from signals. For example, memories and CPU usage, they are signals. They are not alerts. Don't just page people when the CPU is 100%. It's not helpful. So we actually, it's helpful if we build metrics to measure the effectiveness. I think back, not in this job, in Uber, we actually have something like labeling when we do the review, that if there's an alert that is not helpful, we just label it. So eventually we have very good metrics, and then we can improve. But anyway, now there are other things. Actually, right now we're in a good shape that we can just scale up and do everything, but there are some lessons we have learned. One thing is that security design in this kind of setup is really hard. So the centralized and decentralized solutions are, nothing is perfect. So if you want to have good control, then the decentralized solution is not good, but scaling is a headache. So the third thing is the TLS certificates. So when something goes wrong, certificates tend to say, I don't want to tell anything I don't want to show anything to you. When you have secure connection, it's secure. But if you want to debug what's wrong, it's always painful. Now, the next thing is about Terraform. Don't write very complicated Terraform transforms. For example, if you want to create a cluster, do it by small steps, because if state gets complicated, there are some bugs. For example, we run into one bug that the node group ordering is important. So when we rerun Terraform, supposedly it should be nothing, but there's actually recreation and deletion and everything. And if we want to fix them, the Terraform internal state is a huge JSON blob. Nobody knows about it. And we can't mess up with it. So keep it small and simple. The next part is the lessons learned about certificates. So we generate certificates, but sometimes issuers like Zero SSL, they have their service partially going down. And we are confused why we can't get certificates. And for that half day, we can't onboard any customers. But it's, well, I hope there are no people here in Zero SSL, but it's sometimes they just have this situation, and we don't even know who to contact. So we are actually thinking maybe if this happens frequently, we need to build, say, we have 2 issuers as a backup. And then if one goes down, we can use the other. Similar thing is like a Helm repo. So we install, for example, 5 third-party Helm repos, like Bitnami, Apache, whatever, somewhere. It's very helpful and convenient. We don't run this repo, right? But we have 5 of them. Sometimes in the weekend, some of the Helm repo, their services, they goes down. And because there's a file in the chain, anyone goes down, it can block our upgrade. So it will end up eventually, if we have too many, we have very low availability. So if possible, we probably have to serve them by ourselves, say copy one into ourselves. And if things goes down, at least we know who to page, who to bring up and prepare it, right? I think we are probably close. There are a lot of things we can actually do, like in future we can do the design improvement on layer things. For this setup or architecture, we can actually run anything other than Apache Pinot, right? It's just one app. We can install something else. So there are other things like resource efficiency. We can just say this solution could also be run as our own traditional SaaS. In that case, we hope to just stack things together to be efficient. There are things like no downtime upgrade. It's very helpful, but it's really hard to achieve. And there are things like cluster federation, whatever things there. But I think we're pretty much everything on it. So I think that's everything I want to talk about. I hope it's not too fast. I tend to talk very fast when